Yeah, so it's interesting. If you talk to people that have been focused on CCS for a long time, utilization is not a solution, right? If your source is fossil, then utilization is not a solution, because it's just a delayed emission. And in fact, if you take emissions from a fossil fuel source and you go through the liquefaction process, you put it into trucks, drive it around, you actually increase emissions overall rather than reduce it. So it's not a climate solution, and that's why also when I was working on CCS a few years ago, we didn't think about utilization as a solution. Of course, this changes when your CO2 has an atmospheric source, right? When the CO2 is coming from the atmosphere, you can essentially cycle it through, because when it's emitted from the use, it goes back to being a source for more DAC, right? So that's a little bit on that perspective. What we see is that utilization is the gateway to large scale engineered sequestration. If you look around the world, for example, in the US, the industrial CO2 gas market is more than 10 million tons a year. So we'd estimate that almost 100 million tons are used per year to produce vegetables, food, drinking water. For example, pH regulation in drinking water needs CO2. Medicines, welding, you need CO2 as a purge gas, and there's so many industries that need CO2. And our approach is that if we can start, and they don't need that much necessarily for one site, and that's a good thing for us, because we can do a little bit what solar did, right? Solar started out on satellites, then went into lighthouses, went into your calculator, went into rooftops, and now is rolled out in huge volumes. And it's all because you build parks and not plants, right? And what we're seeing with utilization, the current utilization of CO2, is that there are shortages. Northeast in the US, in Iceland, in New Zealand, in Australia, you see many places where the CO2 supply is at risk. And why is that happening? Well, it's actually happening to some degree because of sequestration, right? So if a big fertilizer plant is no longer going to send the CO2 for utilization because they want to sequester, if they send it for utilization, they still have to count it as their own emitted source. Like they don't want to have that emission. So if a fertilizer plant wants to reduce their emission, they have to either stop emitting or they have to sequester it. And for utilization use cases, that's the same effect. You're not going to get that CO2 anymore. So that's actually, sequestration is somehow driving the interest in DAC for utilization. But we and as I mean, I guess you could say, for if you're depending on a waste product and the producer of that waste wants to become zero waste, you have an issue, right? And so that's why that drive on the utilization side is happening for DAC. But we also see that the sequestration projects for CCU, so carbon capture and storage from point sources, is also driving big opportunities for DAC. Because what happens with that is that you get economies of scale of storage, which you can also then use to inject CO2 from DAC machines. So that's also driving. There's a great dynamic between utilization and sequestration, actually. From our perspective, our launch markets are the current CCU sector. So we have greenhouses, wastewater processing, and food beverage industries as pioneering markets. But we have also won major contracts in the CDR space, where the CO2 from our machines is being injected underground. And we're also being contracted for Power-to-X projects where the developers are looking to produce synthetic methane, methanol, aviation fuels, basically where you have a lot of renewable energy with not much on-site utilization potential. Those things make sense because you can actually transport those energy vectors, for example, to a country like Japan, where I lived for a year, that imports 90% of its energy consumed, and all of that being fossil fuels today. Power-to-X potentially has a way of has a role to play in transporting sunlight from, for example, Australia to Japan.